This demonstration video shows an implementation of the Cyest performance diagnostics solution that is developed on our enterprise modeling environment. Relating the variables and business logic in an underlying model provides another level of intelligent reporting that goes beyond traditional BI reporting. The intention of the solution is to proactively identify and prioritize management action by understanding what is happening in the business, where the deviation is happening, why the deviation is happening, and how to go about getting back onto plan. The Cyest performance diagnostics solution in this example is built to model a gold mine, but can be adapted to the context of other mining resource types as well. This demonstration model consists of 3 months of daily data, but the solution can be configured in terms of any time frame and time granularity down to shift level if required. The screen flow is aligned to the contextual questions what, where, why, and how. The Cyest performance diagnostic solution is based on the basic mine equation, or BME, shown in a value driver tree, or VDT. The key drivers of production are highlighted in green. The planned and the actual values are compared to each other in the VDT. The production forecast gives context to the gold mine production. We can see the current cumulative performance compared to that of the planned cumulative performance up to the currently selected day. The mine structure is used to choose which location to look at. The user may also choose to look at either the graph for cumulative meters squared broken or cumulative gold broken for the selected location. We start by showing a chart for the cumulative gold broken on the mine for the first quarter of 2013. Assuming that we're now on the 13th of February, or day 44, you can see the planned and actual performance. We can see the predicted forecast line, predicting where the production will be based on year-to-date achieved rates. The forecast as planned line shows where production will end if it continues from the selected day according to the plan going forward. The best achievable line shows the maximum performance achievable based on the best actual achievements in the underlying data over the last 43 days. These forecasts can be applied to each location of the mine, from group level down to panel level. Using the search function, we can easily navigate through the mine structure to find a specific location. We now have a view on what is happening in terms of production, and also what the forecast will be going forward if the current performance trend continues. The run rate analysis graphs compare the planned average production rate to the achieved average production rate, and also the run rate required going forward to be able to achieve the planned production target. This concept is very much like what is used in cricket terms, but applied in detail to the mining context. 4 graphs help the user with evaluating performance. The cumulative run rate graph compares the cumulative actual production to the planned production average to reach the planned target. The run rate worm shows how the cumulative actual run rate varies to the required average production rate. The cumulative run rate analysis graph compares this required average production rate to the actual average rate achieved to date. The variance is shown, as well as the required average production rate going forward to achieve the planned target for the period. The daily production graph shows the day-by-day production to date compared to that of the average planned rate to give an indication of daily variability relative to the required rate. And the daily production analysis graph compares the required production rate with the actual production rate for the selected day, as well as the variance between them. The run rate analysis screens are important as they give an ideal view on the required production rate to achieve the cumulative production target. We now understand what is happening, what the forecast is, and also what the average required production rate going forward is. We now want to look at the performance of the drivers of production, so we navigate to the production dashboards. The production dashboards gives an overview of the main KPIs and how they vary between the planned and actuals achieved. The total gold broken, CMGTs, meter squared broken, face length, and face advance are given for the selected day, or alternatively for cumulative production to date. Depending on the underlying data availability, this can be extended to more detailed drivers, such as lost blast counts and reasons, and so on. A production manager or mine overseer can drill down to specific areas to get an overview of performance. Due to this performance diagnostic solution consisting of an underlying mathematical model that relates the production variables and business dynamics, a powerful analytical capability that adds intelligence over traditional reporting is provided. We wish to focus and prioritize management attention to the relevant areas that are contributing the most to the variance in performance, and also understand why this variance is occurring in these areas so that appropriate interventions can be implemented. The next screens will allow us to understand where the variance is occurring between planned and actual values. The underlying model allows powerful analytical techniques to drill down and understand where the deviation is being caused. Two views help us determine where there is significant deviation. The variance drill-through view allows the user to navigate through the mine structure based on either meter squared variance or gold production variance. These waterfall charts show how the underlying individual areas contribute to the total variance between the planned and actual performance. This allows the user to manually drill through to find specific areas with a large variance to plan. This functionality can be extended to any variables existing in the model to navigate through the variances in the mine. The following ranking by variance screen highlights how the panels compare to the under and over performance of all the panels. The table ranks all the panels in an unindented list for direct comparison. A graphical comparison of all the panels is also shown, with the selected panel or panels within a raise line or level being highlighted in red. This is another way to understand performance and how it is compared across the mine. These views can be configured to show different location rankings. For example, if the required view is to rank raise lines, the view can be customized to compare the variables at a raise line level. This adds more value to comparing the performance at a certain level and easily navigating to underachieving areas. For this example, we will select the two worst performing panels to replan. Panel 3, found in raise line 1 on level 1, and panel 6, found in raise line 2 on level 2. We navigate to the panels in the tree and select the Replan panel tick box. Having the context of where in the mine the underperformance is occurring, management now needs to understand why the variance is occurring. Again, the underlying model that relates the drivers of production allows an analysis to be performed that ranks the top reasons for variance. We first look at the top reasons for variance, highlighting the key drivers on panel level across the whole mine that have caused the overall deviation from the planned gold production. We get insight into where and why there is a significant deviation in this overall picture. The graph shows the percentage variance of the driver and the absolute impact on the production between the plan and the actuals. As expected, the panels which were identified as performing the most poorly compared to plan, being panel 3 and panel 6, have drivers that perform poorly and give the most significant negative variance to plan. We would then like to look at specific locations' reasons for variance, so we navigate to the Variance Analysis screen. The top graph highlights the reasons for variance for the selected location. Similarly to the previous screen, the graph shows both the percentage variance between actual and plan for that particular variable, which is what is done in traditional reporting, but more importantly, how much in absolute terms that particular variable has caused in lost production. This is a critical piece of information as it focuses management attention on the items causing the greatest impact. In this example, Only the 4 main drivers of production are analyzed, but depending on the data acquisition systems and availability of the detailed underlying data, a more detailed view of the reasons for variance can be displayed. A control chart is an important analysis of the underlying variable, as it shows the variability and trend in the underlying variable, and gives management insight into whether the variable is in control or not. We now understand why the variance is occurring at a particular location. The question now is what management could do about it to get back onto plan, or alternatively, have a more realistic plan of what will be achieved. Having selected the panels to replan, we can either select the To-Do List tab, giving a list of the panels that we selected for replanning in the preceding steps, or go to the Mind tree to select other panels to replan. For this example, we will replan panels using the To-Do list. We select a panel and the driver we would like to replan. Note that this example has limited the amount of drivers to replan. This list can, however, be extended further to include other controllable drivers that affect production. On selection of a driver, a histogram and statistics table appear. The histogram compares the current replanned value to historical data of the selected driver. The statistics table gives us the historical data statistics, as well as the value and confidence level of the planned and replanned scenarios. The max replan percentage that is achievable based on the specific historical achievements of that panel is also shown, giving us an idea of how much we can relatively achieve based on the historical maximum production. These simple statistics thus give a powerful view of the confidence in the plan and what potentially can be achieved going forward. Importantly, everyone plans at a different level of confidence. Optimistic, pessimistic, and realistic targets are aggregated to an overall mine plan without an understanding of the overall confidence level of achieving the plan. We can now make an informed decision on how much to replan on a particular panel based on historical achievements and within a required confidence. This reduces the occurrences where promises are made that production will be caught up, only to underperform time and time again. The software rather introduces a more informed and objective view based on historical performance to give realistic plans. Some panels may in fact require higher performance targets going forward, as their original plans had a 100% confidence based on the historical performance. In the context of this example, Panel 3 has a face length planned value that is much higher than of that achieved in the past. Having a realistic plan will therefore give a more accurate representation of what the panel can realistically target at the quarter end. Reducing the current planned face length by 50% now gives us a production plan with an improved confidence level of over 51%, which is still low, but significantly better than the previous 0% confidence. Panel 6 shows potential in improving the plan for face length and also face advance. Increasing both drivers by 20% allows the replan to meet the original target, whilst ensuring that we have not set a new but unreachable production target. This performance diagnostic solution is not intended to replace existing reporting solutions that are required for traditional reporting, but rather provides a live and proactive intelligent reporting layer that identifies and prioritizes management attentions on the areas and production drivers that are important. Often, management spends their time fighting fires that in some cases are not necessary, where they should rather focus on what is important and will give the best possible outcomes. This is an example of how this can be applied to a gold mining operation using data that could be made available. We have found out what is happening to the production, where the areas of improvement are, why there is a significant deviation from the plan, and how we could potentially replan to set a realistic goal with best possible outcomes at the required confidence level. For more information, please refer to our full range of demo videos and brochures on our website at www.cyestanalytics.com.